Hello and welcome to this lecture series of supervised classification. I, Dr. Snehal Joshi, welcome you for this lecture and I hope you will learn about SVM, which is abbreviation of popular supervised classification algorithm called support vector machine. Now, why SVM? What is significance of SVM? Well, when we classify the data points, we assume they are linearly separatable. But when the data types are not linearly separatable, then we use SVM and it is an obvious choice. Consider this example. Here, in first example, the data points are represented as checks and dots. The checks represent particular category of and data points expressed by dots are representing another category. Here, using line, the data points can be classified very clearly. Consider the next example. In this particular example, the data points are mixed. They cannot be separated linearly. So, we choose to use higher order polynomial which results into higher dimensionality, and we use a plane which separate these data points. Let us take an example to understand SVM. In coming lectures, we will implement and write code using Python to understand SVM. We have a data set which contain hundreds of human cell samples of potential cancer patients who were medically verified about the risk of developing cancer. Analyzing the original data, it shows that many of the characteristics separates benign and malignant samples. Our goal is to use these characteristics to develop a classification model which help in early identification of new samples to classify them as whether they fall in the category of benign or malignant. This particular slide, if you look at that, it shows some sample data set having 11 attributes. The class attribute, the last one, it is a categorical type and having value of benign or malignant, that means 0 or 1. Here, the graph shows yellow and blue dots representing benign and malignant respectively. This is data point representation of small portion of data set which signify that both class malignant and benign are not linearly separable. Okay, let us go ahead. Now, there are two challenging questions to consider. First one is, how do we transfer the data in such a way that we can have a separator as hyperplane? And the second obvious question is, how can we find best or optimized hyperplane separator after this particular transformation? The graph clearly shows that both the categories are separated with a curve and not with a line. It represents linearly non-separable data set, and let us transfer these data points in higher dimensional space. As shown in the graph, the data points are mapped in three-dimensional space, separated in three-dimensional space. You can see the hyperplane dividing them. So, with this particular slide, we conclude and will continue with the next lecture. In the next lecture, we will go ahead and continue with the same slide. Thank you very much. Good day.